f of x equal to absolute value of, again absolute value of x minus 1. This is not differentiable yet. Okay. So for a function to be not differentiable, either it is not continuous, continuity is breaking, or it is not smooth. What is not smooth? Not smooth means there's sharp corners like this, or sharp spikes like this, or some breaks like this, or whatsoever. Okay, let us try to draw the graph of this function. We have absolute value and again absolute value. Let's start with absolute value of x. First let's start with x, y equal to x. Then what is absolute value of x? Whatever is negative part, we will make it positive. So absolute value of x is this part, whatever this part flipped upwards. Right. So all negatives, we are making them positive. This is absolute value of x. Right. So now absolute value of x minus 1. We are taking till this part. Absolute value of x minus 1. If f of x is absolute value of x, this is f of x minus c. F of x plus c or minus c, whatever. So the entire graph shifted 1 unit downwards. Right. This one is absolute value of x minus 1. Okay. So absolute value of x minus 1 is entire graph of absolute value of x shifted 1 unit downwards. This is absolute value of x minus 1. Okay. Now we are doing again absolute value of this. Again absolute value of this, what will happen? If I have to do again absolute value of this, whatever negative part is there, right? This one and this one, we just flip it upwards. It will just make it mirror image of with respect to x-axis. So this part will become this part. So this part, this, and this, all four put together will make it absolute value of x minus 1. So this is our final graph. What is our final graph? This. Right. Obviously, this point is 0, minus 1. 0, minus 1. And what is this point? This is minus 1, 0. Right. And what is this point? This is plus 1, 0. Obviously, if you flip it, what will happen? This point, this is minus 1. This is plus 1. This is again 0, 1. Right. So let me show you the graph. Actually, it will look like this. Y-axis 1, x-axis minus 1, x-axis plus 1. Right. Now, obviously, we have sharp edges here, sharp corners here at minus 1 and at this point, which is nothing but when x equal to 0, x equal to minus 1, x equal to plus 1, we have sharp corners. Right. Obviously, at these three places, it is not differentiable. Differentiable, why? It is not differentiable because if we approach this graph from the left hand side, right, so then this is the slope. If you approach it from the right hand side, this is the slope. The slopes are not matching. Similarly, at this point, if you are approaching from the left hand side, this is the slope, right side, this is the slope. So at this point, you cannot say clearly what is the slope, whether it is positive or it is negative, we cannot say. Here also, it is positive or it is negative, we cannot say whether the slope is plus 1, minus 1, plus whatever, plus positive or negative, we cannot clearly say. So that's why the function is not differentiable at these 3 points when x equal to minus 1, 0 and 1. So that is the question. 0 plus 1 minus 1, it is not differentiable. Right, guys? Very, very simple problem. We just need to do basic curve sketching. Right. Or otherwise, if we want to do the other way also, we can still do. When x greater than 0, when x less than 0, we have to create all the equations and then use the limit f of x naught plus h minus f of x naught by h when h tends to 0, and we'll evaluate these limits 0 plus 0 minus whatever. If we do all that way also, we'll still be able to find out whether it is differentiable at 0, 1, minus 1, etc. But this is an easier way, where we just draw the graph and find out where are the sharp corners. Right, guys? Thank you.